is a company that, through MIT, Caltech, University of Illinois in Aalborg, and also National University of Ireland, Maynooth, licenses several, the core patent portfolio for random linear network coding, which is really as far as we can tell, the only practical network coding technology out there, certainly the only scalable one. And it also provides the sort of consulting and expertise that's needed to incorporate random linear network coding into different products. Steinwolf provides the development kit, if you will, the main tools, both for the finite field computations that underpin network coding and for doing random linear network coding itself over a wide variety of platforms, not just, if you will, the necessary platforms for operating systems on laptops, but over Intel, ARM, and other types of lower level architectures, and of course over Android and popular mobile operating systems. A chocolate cloud works on top of the developer's toolkit, sometimes called the software developer's kit, SDK, of Steinwolf, and provides storage solutions, distributed storage solutions relying on random linear network coding. For instance, it allows you to store your data over various existing services, say, Dropbox, Amazon, Box, what have you, and both accelerate the download and enhance the robustness and security by making use of the inability of a curious, what we call eavesdropper, but in this case it would be somebody maybe gaining access to your account rather than simply overhearing. Even if one of your accounts is broken into, we rely on the inherent robustness and security of random linear network coding to make sure that your data is protected. One of the clients of Steinwolf is Cisco, which has incorporated the software in its video delivery for Stadia. So in a stadium, you would have the problem of being able to provide video delivery when you have a large density of heavy density of users, and there are interesting products to be able to provide services, for instance, instant replay or other media that would be of interest to people attending a sporting event in a stadium. The problem of broadcasting reliably in dense areas is one that has been of growing interest, both as the consumption of video goes up, but simultaneously consumption of wireless video has really led that growth. Other examples where random linear coding is particularly useful is, for instance, in the new emerging fifth generation wireless systems, which the consensus has, it's my belief, but is also, I think, a consensus both in the academic and the industrial communities, that it will require the ability to marry a highly heterogeneous set of networks, the Wi-Fi networks, networks that are very similar to the current fourth generation, but also some emerging physical layer technologies such as millimeter waves. And the ability to integrate all of those different types of technologies rather than dealing with one at a time is fairly challenging, and I would say it's really, as far as we can say, almost impossible in the absence of a distributed coding approach, and random linear coding gives you that distributed coding approach, composable, scalable coding.